Hello everybody, this is Introduction to the Business Analytics using Excel, Lesson 1. My name is Boris Furman and I am developer at Vistra Corp at LBM Group. So here's our class schedule. We're going to have 4 classes starting at April 30th and ending on May 21st. So the first class, it's a basic Excel, table sorting, filtering. Next class, we're going to do Power Query, cleaning data. On 5.14, we do and analyze data pivot tables. And 5.11, visualizations with charts and building dashboards. Here's the objective of our class: data analysis overview, Microsoft tools for data analysis, basics of Excel. We're going to look at addressing of the cells, formulas, tables, sorting, and filtering. So what is the data analysis and why it's so important to study it? Data analysis is basically a process of converting data into actionable information. In any company, we collect a lot of data, and in different multiple systems, in multiple different formats. Very often those formats are non-standard form and need to be transformed so that we can work with it. We can do, so in the original form we usually cannot do searches, filtering, and a lot of analysis. So the first step is to collect the data in whatever format is best for those systems. In the example here, we have this order items. Like you can see, the data is all different type of data grouped in the same column. This data is not very good at processing. We cannot really do filtering. We cannot do searching. So once we collect the data, we clean the data. So we move it into more standard format, where we have columns. Each column corresponds to the same data type, and we remove duplicates. We also very often fill the missing values. Many tools are designed to work with this standard format. So once its data is cleaned, next step, we go into analysis. Analysis basically gives us some information about the data, summary, statistics, and grouping. When you look at the list of records, it's very hard to make a lot of sense, especially if you have a lot of records. If, like in this example, you have under 10 records, you can make some judgments about the data. However, it's hard to analyze data that is hundreds of thousands or millions rows. So we need to have some summary statistics or grouping to give us some kind of a sense of the data. So in this particular example, we have a pivot table. And a pivot table, of course, provides us a lot more information than just a list of data. In this particular pivot table, we can see that we have 2 sales reps. And each sales rep, we can see sales by sales rep. $528 for Alex and $72 for John. Total sales for our company is $600. We can see that Alex sold for $184 for Alex Mitten product and $72 for the syrup. Actually, John sells $72 for syrup and Alex sells $44 for chai. So we can also see grand total for each product. So it's a lot of information that we can make sense of. But it's better if data is actually, information is visualized. Here we have the actual visualization of the same data, and it's a lot more understandable that Alex oversells John by almost 4 times. You can see that what kind of products Alex sells, and it's a lot more understandable than by just looking by raw numbers. So once we're done with the visualization, we usually do inference. In this particular class, we will not work with inference of data. Basically, we're going to look in the future. We try to predict what will happen if we buy, let's say, more products of this kind, of that kind, if we raise prices, if we lower prices. Inference into the future, usually done in machine learning models. And once we do the inference, we go back to, again, collecting more data to improve our inference and learn more about the data. So we have a circle that continues pretty much constantly, and in each iteration we get improvement. Many different vendors provide tools for data analysis and machine learning and analytics. So in this particular case, we're going to look at tools provided by Microsoft. In any particular vendor, they will have products to transform data, to summarize data, to visualize data, and to do machine learning. Microsoft also provides Excel that's used in any stack, in any vendor. So that's why Excel is such a unique product. Excel is such a unique product because it actually can participate in every single stage of data analysis. While it has limitation in every single stage of the data analysis, for example, there is a limitation how much data Excel can collect, how much it can process, what kind of visualization are available, what kind of transformation you can do, what kind of machine learning predictions you can do. Actually, machine learning predictions, you can do anything because Excel right now is integrated with Python, but there is still restrictions on size of the models. So there are a lot of limitations what you can do with Excel, but it's on every desktop, and it can participate in every stage. So in a lot of situations, Excel is just enough. So that's why Excel is such a great tool to start learning business intelligence and data analysis. So let's go through the stages. We have first stage, which is collect stage. So we collect data in CSV files, in Excel files, in SQL Server databases, and many other sources, Azure Storage, and so on and so forth. Once we collect the data, we need to process and organize it. What we can do with this processing is in worksheets. We can do it inside the formulas. We can do it in data flows. We can do it in Power Query. Power Query is part of Excel, and it's also part of Power BI. We will cover Power Query in our class. Power Query uses M language that's also runs in data flows in the cloud, so you can actually run a lot larger workloads in data flows than you can do in Power Query. And Power Query is right now also integrated with Python. So basically there's a lot of things you can do with Power Query to transform the data. So once you transform the data, you need to visualize the data, and you need to summarize the data and analyze the data. And again, we can do it inside worksheets. We can do it using pivot tables. You can do it using formulas, Excel formulas. You can use it using DAX, which is part of Power BI and Excel product called Power Query. Power Pivot. So DAX is a Power Pivot, part of Power Pivot and Power BI. So you can see that those tools intersect. A lot of functionality is used from Excel to Power BI. And of course, you can do a lot of summarization and data analysis in Python. Very, very sophisticated data analysis can be done in Python beyond any of the other tools, but it requires more skill. So sometimes you just don't need it, but you can pick an easier tool. Visualization can be also done in Excel and in Power BI. Power BI gives us more flexibility to share our visualizations on the web, on the mobile devices. But Excel can do also a lot of good visualizations. And you can integrate also Python with Excel or Power BI to do very advanced visualizations. Then we have, for prediction, we have machine learning. Excel has some models already that you can use. You can integrate Python into Excel lately, that you can do very sophisticated machine learning algorithms with a limited size, but pretty sophisticated inside Excel. And you can use Python standalone. You can use it inside Machine Learning Studio in Azure. So this is going to be the end of our overview. We're going to move to the next step, which is Excel basics. Excel holds data in cells. Each cell is really represents an area in our worksheet. So this cell has an address, and this particular address is J8. So inside the cell, it can contain data. Let's say right now it can contain data, let's say hello world. It can contain data. It can also contain formulas. We're going to go a lot through the formulas instead of data. It also contains format, the way this data is displayed. I'll show you. Let me create a playground. So for example, we have a date. This date is January 1st, 2024. So if we want to do format and change format of this date, let's say we want to display it in this format, we still see the same date, just displayed differently. Excel holds dates in a numeric format. So basically, formats can change, but data may stay the same. So going back, cell can contain data, formatting of the data, background colors of the data can contain formulas. Now, cells also can be in different modes. Like if you type something into a cell, let's say as you start typing, you go from view mode to enter mode. If you want to go back to the cell and change what's inside the data, inside the cell, you can either double click or you can press F2 and you can add more information to the cell. If you just select the cell and start typing, you will override the cell. If you type something in the cell and press enter, you move to the next cell under it. To go into the same line, you can select the cell and start typing. Enter, and it will kind of go along your selection. There are two types of handles actually three types of handles that cell may have. One is a move handle. So if we have, let's say, a number and we want to move it, you see this little cross, you move it around, you can move cell around. Another handle is a fill handle. Fill handle is basically Excel is trying to predict what we want in the next cell. I'll give you a very easy example. We're going to do more of fill handle. So if I have 1, 2, 3, and 4, I select this range of cells and drag it to the right. Excel is trying to figure out, oh, okay, 1, 2, 3, 4, next one should be 5. Figure out the sequence. Let's try another sequence. 1, 3, 5. So it's each one previous one plus 2. So Excel figures it out too. 5, 7, 9. Same thing with dates. Or we can actually use string. Department 1, department 2. Let's see if Excel is smart enough. And it is. Department 3, department 4, and so on and so forth. So there is very sophisticated kind of logic that Excel is trying to guess what exactly we are trying to do, and very often is doing a good job. Okay, we did move handle, fill handle. Okay, cell can have a name. Very often, let's say we want to create an equation for length of a circle. So I'll put here number pi, which is 314, and I want to put some name, and I can name the cell. Let's say I'll call it pi value. So now if I want to do my formula for length of a circle, I can do here, say 2 times pi value. Let me do another one is radius. Let's say here we're gonna save pi value. Here we'll save radius. So radius will be, let's say 22. And somewhere here we want to display the length of a circle, and I'll call this cell radius value. So this is pi value, this is radius value. Somewhere, doesn't matter where in the worksheet, I want to use these values. 2 times pi values times radius values. So no matter if I move this cell somewhere else, the value it will still refer to those cells that I named. 2 pi value times radius values. It's a very useful feature, and we're going to use it a lot in this class. Okay, collection of cells is called worksheet. So worksheet is what you see. We have different worksheets. And collections of worksheet is called workbook. Workbook basically represents Excel file. One more thing we're going to cover is different type of paste that we can do. I'm sure you're all aware of cut and paste functionality that you do in all applications. Excel has a special paste application, paste type. So for example, I have value A, value B. Let's say value A is 3, value B is 5, and value C is 3 times 5, 15. So what we see here is this cell contains value, this cell contains value, and this cell contains formula. I want to copy these cells, but I don't want to copy them as a formula. I want to copy them as all values. So what I'm doing is I'm selecting the cells and right click, and the different type of paste. Very useful is to paste values only. So when you paste values only, now everything is pasted, every value here is value only, not the formulas. We're going to use this feature a lot, so please pay attention to that. Okay, now let's move to addressing. This topic is usually very confusing, so I will do more demonstration on the playground, but please look at the slide in your handout. So let me create the workbook. What we're gonna do here, we're gonna build multiplication table. So we have values of x, 1, 2, 3. Let's use fill handle, go to 16. We're going to do values of y, 1, 2, 3. Sorry. So, how would we build multiplication table? In each cell, I want to multiply, let's say in this one, 2 times 2. I expect here to be 4. 3 times 4. I expect here to be 12, and so on and so forth. So I want to put formulas. Like I can put formulas here, like 2 times 2. Yeah, it's 4. 5 times 7 is 35. But if I want to build large multiplication table, putting all these formulas manually is not a good idea. So what we're going to do is we're going to let's show the ribbon. Okay. Let me make it a little bit nicer. Okay. So what we're going to do the first cell, which is this value, which we call y, times this value, which we call x, and y. So if we try to use fill handle and move to the next cell, we get the right value. 1 times 2 is 2, that's correct. Let's try one more cell. We get 6. 1 times 3 is 3, not 6. Let's see one, maybe a couple more. And you see, as we drag to the right, it's not working correctly. What about down? 1 times 2 is 2, that's correct. Let's drag down, it also doesn't work. So fill handle does not work. Excel is not guessing right our intention like we thought it would. So we need to help him a little bit. Let's see. Let's see what Excel is trying to do, what Excel is guessing we were trying to do. So the first cell, it was saying multiply cell to the left with cell above it. That's exactly what we want. What about this next cell? That's again one cell to the left with one cell above it. In this particular case, that's not what we want. We want for the first multiplier not to be I10, not to be I10, we want it to be H10. H10. So we need to freeze the column for this first multiplier. As you can see, this one says 1 to the left. We don't need 1 to the left. We need to stay at H10. We need to freeze the column. To freeze the column, we put a $sign in front of the column. Let's try to drag it to the right. So far it's working. It's working. Let's go all the way. It works. 1 times 16 is 16. Let's go down. Still doesn't work. Let's look what's going on. So 1 to the left was 1 above. That's correct. 1 in this scale, 1 to the left was 1 above. We don't want to be 1 above. We want to freeze this row to be not, we don't want to multiply by row 10. We want it to be at row 9. We want to apply this value. We want I9, not I10. So we need to go back to this first and say don't freeze this 9. So as you change rows, do not change. We're going to read as you go down the rows, stay at row 9. Stay at this particular row. So freeze row 9. Let's go down. It looks correct now. 1 times 18 is 18. Let's go all the way to the right. Let's check ourselves something easy. 10 times 16 is 160. Double click and you see that formula actually refers to the right cells. The blue is gotten from here and red is gotten from above. So everything looks good. We can go ahead and fill. We can go ahead and fill our whole multiplication table. By default, before we did put those $signs, that was called a relative formatting. Basically, Excel figures out what was the position of the cells that you clicked on relative to the cell of the cell that you take data from relative to the cell of the formula, and figures out as you move the formula cells, it takes those same relatively cells compared to the formula cell. Like in our case, it was 1 to the left and 1 above. But if you freeze, you tell Excel which portion of the address that can change. So in our particular case, here we said column cannot change. Here we said row cannot change. So this is called mixed addressing. You can also have a fixed address, absolute address, where you say to Excel, do not change. Always refer to this particular cell. As you use fill handle, I want value in this particular cell. So let's say I have this cell and I call it B, okay, or A. So let's say value A will be 10. So I want to multiply all x times y or x times y plus 10, right? I want to do formula x times y plus a. So what I will do is I'll come here and I will say, okay, and plus, and I will say always refer to the value a. Do not change value a. Let me first not to freeze it. Let's do this. So 1 times 1 is 1, plus 10 is 11. That's correct. Let's do fill handle. And you see that 1 times 2 is 2, but plus 10 should give us 12. But you see that as we moved this cell 1 to the right, this cell also moved 1 to the right. So because we use relative addressing, we need to change that. We need to say, no, do not use relative addressing, fix the A cell, always refer to the A cell exactly where it is. Refer to it right here. So I will even put border around it. So say cell, do not change the cell. The cell is fixed. So now let's do the fill handle. And let's check. Let's say this column. 2 times 5 is 10 plus 10 is 20. That's correct. That's correct value. 6 times 2 is 12 plus 10 is 22. So now we have a formula x times y plus a. Okay, so at home, please look at this example. That's the same logic that I explained. In this particular case, we're doing formula x times y plus b. B is 12. Yeah, if we change the value of 12 to, let's say, 11, all the records, all the values are changing. Excel is very interactive. You change one portion of a formula, everything gets updated. Let's change it to 100. All the values gets updated to the right value of the formula. Every formula has y times x plus b. Y times x plus b. Now let's talk a little bit about formulas. Formulas are very important in Excel. There are a lot of logic that's available. You can see here there are different formulas that's available in Excel that given to us basically out of the box for free. There are different, there's the logical formulas, text formulas, date and time formulas, math trigger formulas, financial formulas, statistical formulas, so on and so forth. We can create our own formulas, but the most important thing is really to understand what the principle of the formula, and once you understand the principle of the formula, there is no way anybody pretty much can learn all the formulas in Excel. Plus we can create our own custom formulas. Most important thing is to understand the principle. Once you understand the principle, you can build your own formulas or use the formulas already in Excel. You just have to learn and find the right formula. So what is a formula, or what we say function? Formula is a function, representation of a function. If you studied mathematics, you probably learned that function is a mapping between inputs and outputs. In business, we don't think about this way, but it's pretty much still mapping between inputs and outputs. I will give an example of a business case. We're going to create a function that calculates employee salary. The business requirement says that employee has a base salary. Alex has base salary of $50,000 a year. He's a salesman, but if he sells absolutely nothing, he still gets $50,000 a year. Michael, not as lucky, $45,000. Then they work on commission. The commission rule is that if they sell less than $10,000, their commission rate is 5% to encourage them to sell more. But if they sell more than $10,000, the commission rate is 3%. That's a business rule. If sales are more than 10,000, commission rate 5%, otherwise 3%. So what is the input of this function? We have inputs, we have a function logic, and we have an output. Then inputs are base salary that the employee makes. The input is also cutoff amount for the commission. Greater than that amount will be 1%, less than that amount will be some other percent. Input is also percent less than cutoff amount. What is the percent less than cutoff amount? And what is the percent that's greater than cutoff amount? We also need to know what is the sale amount, so we can calculate the amount of commission amount. And then once you have the commission amount, we're going to add it to base salary. So the person who uses this function does not really need to understand the logic inside of it. He just needs to know, oh, you want me to tell you the employee salary? Give me this 5 inputs. Base salary of the employee, the cutoff amount, percent greater than, percent less than, and the sales amount. And if I have this information, I will produce for you the employee salary. Based on the business requirement, we say, oh, if determine first commission percent, because it depends on the cutoff amount. Once we got the commission percent, determine the commission sales amount, the commission amount. Once we have commission amount, add it to the base salary, and that will be the employer salary. How would we do it? If we have only 3 employees, that's okay. We can just put employees' base salaries. We can put sales. We can look at our rule, say, oh, it's less than 10,000, and commission is 5%. It's greater than 10,000, commission is 3%. All right, commission amount is, of course, sales times percent amount. That's going to be commission amount. And employee salary is commission amount plus base salary. That's employee salary. Then here we can actually put a sum. Very useful function that takes a range. Functions usually can take either values or range of values, right? So sum takes a range of value, gives us a number, sum. And another sum takes a range of values. So that's okay. But if we have lots of rows, we don't want manually figure out this percent. So we need to use some other Excel formula, which is if formula, that says if sales is greater than this cutoff amount, we make this cutoff amount with absolute formatting. So just we put this cutoff amount percent greater than, percent less than into the cells, and we're going to refer them with absolute formatting, absolute addressing, sorry. We're going to refer them with absolute addressing. So if sales are greater than cutoff amount, then use 5%. Otherwise, use 3%. And you can see we use 3%. Let's change the cutoff amount. If greater than, let's use 3%. If less than, let's use 5%, let's say. Okay, but formula does not change. Formula is still the same. Now formula says if it's less than 8,000, 5%. Greater than 8,000, 3%. Then calculate commission amount and give us employee salary. So inputs are base salary, these amounts, cutoff amount, percent amounts, and the sale amount. And the output is employee salary. So To derive our business formula, we use a lot of built-in formulas provided by Excel. We're going to look at tables in just a moment, but using tables even better than what we just did using ranges, because when we use tables, we can still do the same thing. We put these parameters right here. We're going to use them. But when we figure out commission amount, you'll see that it's actually, we also, all the parameters now look named. So much easier to read the formula. If sales greater than cutoff amount, use % greater. Otherwise, use % less. And we just did is we named these cells. This cell is named cutoff amount, this cell is named percentage, and this cell is named percentage less than. So our formulas look very much readable. This formula is very much readable. If sales are greater than cutoff amount, percentage greater than. Otherwise, percentage less than. I prefer to always be able to read the formula in this type of format, because you can send it to business. That's what I do very often in my work. Let's say we're doing some business calculation and we're developing actual system, let's say in Salesforce. And business gives us requirement of how to, let's say, calculate certain values on the contract, like the electrical contract. And to validate the values, I create this type of formulas, send it to business, and they can understand it in Excel. They read this formulas, Excel formulas, and then I can give it to developers to actually develop the product, and then we can check that Excel calculates the same values in the system later. So it's very, very, very useful. The last portion of our class will be talking about tables. In the beginning, we said that when we clean the data, we like to bring it into standard format, or called proper data set. What is proper data set? Each column has the same type of data. We have spaces around this range empty. It's called proper data set. Our tools are designed to work with this data set. We can just use regular ranges. We don't need to use anything else to hold the data. But it's much better if we would use actual tables. So let me create a playground. And paste. And again, like I said, we like to paste values. We paste values. So we got this table. Now we can insert the table. Insert table. Or you can just use Control T. Let's try to do that. Control T, and it shows you pop-up create table. Here say my table already has headers. We'll take the first row as headers. Click OK. So now we would need to format the data so it kind of makes sense, because this is actual values of the date, but not very readable. You can select. So now when we have a table, as you come down to the table, you see this arrow pointing down. This is selecting of the row. We selected the row, and we can do right click and format cells. But better, do Control number 1. So we got the We got the formatting. How are we going to format the date? Depends how we want to look at it. I actually like this format a lot. So let it be this way. Year, 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 month, month, date, date. Quantity is a number. Numbers are always right adjusted. The strings are always must be left adjusted. Unit price is currency. So let's select it. Control 1 and select currency. Excel still just holds number 24. We can just select how we want to look at it if it's in case of actual currency. So let's look at it this way. So table gives us this ability, plus what we can do with the table is you click anywhere in the table, you can see design of a table. When you have design of a table, you can give a name of the table. Table example 01, let's say. So now, if you're anywhere in the sheet, table you should be able to find this table. Okay, so now that we have table example 01, we didn't name it. Let me name this table example 01. This is how you name the table. Already exists. Okay, we'll look into it later. So what else we can do with the table? We can do searching. We're going to talk about searching in just a little bit. Alex and Clara, and shows us only sales reps Alex and Clara. So we can add to go to our design and add a total row. So now we have a sum of this column. We can come to this sum quantity, and let's say we want to do average quantity. So on average, people buy 2,644 items. Start date, maybe we want to have maximum start date. So the latest start date was 2024-01-02. So that's kind of given to us by tables. Let's talk about sorting. In general, sorting and filtering are two basic operations that you do in data analysis as first steps. Like in any technology, it's just very fundamental two operations, sorting and filtering. If data is not very large, we can see some patterns when we sort. Like for example, if we come here, we want to sort it. Let me go sort it by amount largest first. I can see right away, even if there is a lot of data, but just by sorting, I can see what is the largest sale amount. If I sort it the other way, smallest to largest, I can see the smallest. I can see second smallest. Yeah, it doesn't give me any feel for the data, but still I have some information. What is the largest, what is the smallest? I can, if data set is not very large, I can order by sales rep, and I can see that Alex made 3 sales and Bob made 5 sales, and Claire got 2. So just by doing sorting, I got some data, some information. So we can do sorting by one column, and that's pretty easy to understand. All you do is you go through each row and you sort by Alex. All Alex's rows will be first, all Bob's are second, and all Claire's are third. The values of the row did not change. Rows are sorted. When we sort by sales rep, it's not the column being sorted, it's all the rows are moving with, like row 3 is row 3 no matter how I sort. Alex, row 3 is Alex and $26 sale. So if I sort it some other way, let's say I sorted Z to I, row 3, still Alex, $26 sale. So it's the same row, it just moves in relation with other rows. We need to discuss what is when we try to sort by multiple parameters, what's really is happening. Let's try to take this table, I'll create a playground again, and paste, Control T, I will create a table. I will go ahead and format it. Let's do dates. Quantities are good. If I do Shift, I can select multiple rows. Shift selection. Sorry, not Shift, Control. Then Control 1. And currency. Okay, so I formatted this table. Now what I want to do is I want to first sort by sales rep. Then I want to sell by sales date, and then by sell amount. What does it mean? Let's see. Let's try to do it and see. Excel provides us with this tool. When you go to the data and you click sort, it tells you, okay, how do you want to sort? What is the first column you want to sort? In this particular case, I want to say, okay, let's do first by sales rep. Said, okay. So now what I see is all the records are sorted by sales rep. Here's all Alex's sales. Here's all Bob sales. And here's all Clara sales. So we have 3 different groups. Alex's, Bob's, and Clara's. All other values in each row, we did not pay attention. All we cared about that first Alex's go in one group. So it could be like first group was Alex's is rows 3, 5, 2, but it could have been 2, 5, 3 or or 3 to 5. In any sequence, these rows would be put here. That would be okay with the requirement we gave. That would be sufficient, that would be acceptable. But we want to have sales date to go from largest to smallest. It means that within this Alex's group, we want sales date of 2024-02 go before 2024-01. That's our intent. So let's go back to sorting. And we do add level. So first level we get to this point. Second level we get to sales date. And I actually want to do newest to oldest, meaning that latest sales I want to see first. Let me see what happened now. So let's look at Alex's. You can see that in the group of Alex, all the sales of January 2nd go before January 1st. That's exactly what I was expecting. Let's look at Bob's. Have the same date. So no, yeah. Let me select all Bob's. Same date for Bob. Let's select all Clara's. Same date for Clara. Okay. No, Bob has different dates. Let's pick Bob. 0102, 0102, 0101, 0101. So latest sales are first. Okay, so this way we just sorted by two columns. First by Alex, so first by sales rep, then by sales date. The next sales level will be by sale amount. Let's try to do that. Go to sort, add level, sort. We need to select sort first by sales rep, then by sales date, and then by sale amount. How do we want to sell amount? Smallest to largest. Let's do largest to smallest. Okay, now let's examine. Our first group is all Alex's sales made on January 2nd. In this particular group, we see that sale amount, largest go then smallest. Second group is Alex's sales made on January 1st. That's there is only one member of this group. Second group is Bob's sales made on January 2nd. Largest sale goes before smallest. And the third group is Bob's sales made on January 1st. Largest goes before smallest. Third group is Clara's sales made on January 1st. Largest before smallest. So we sorted by 3 levels, and we can sort by 5 levels, 10 levels, 50 levels. So very important to understand. Go through my notes and you'll see that first we sell by sales rep, then by sale amount. So here I'm explaining the meaning of the groups. As we do this first selection of order by sales rep, we group our results in groups of by actual sales rep, all Alex's, all Bob's, on Clara's. Once we add sales date, now we treat it as multiple groups. We basically divide this group and we put Alex's sales for January 2nd as the first group, then Alex's sales for January 1st as the second group, and then we add sale amount. So basically, it's we gradually making the sorting. In addition to sorting, very important topic is filtering. And that's going to be our last topic of this class. Usually, in the business, we have a lot of data, and business tell us go ahead and here's like 10,000 or million records or 10 million records. Find me the records by certain requirement, right? And once you found those records that I care about, that you need to present it to me, sort them in certain order, and then analyze them. So filtering is done first, then once we filtered the data set with the records we need, we sort it. We sort the data set. To specify the logic of filtering, we use what's called propositional logic or Boolean logic. To understand what the propositional logic or Boolean logic means, I'll explain to you what proposition is. Proposition is a statement that can either be true or false. So what is not a proposition? Proposition, let's say, proposition, not a proposition is something that cannot be answered with true or false. Let's say the question, what do you think about Alex, is not a proposition, because you can tell me how much money does Alex makes per year is not a proposition, because you can tell me that he makes 50,000 a year, a million a year, whatever his salary is. It's not true or false question. It's a question about how much money he makes per year, how much commission, what's the amount of sales he made. But if we're talking about sales amount, proposition is, did Alex on January 2nd, did he sell more than $10,000? That's true or false question. In this particular instance, it is true statement. He did sell more than $10,000. In the transaction number 3, sales rep was Clara. That's a propositional question. That's a propositional statement. The answer is false. In in transaction with ID 3, sales rep was Alex. So it's a true or false question. That's called proposition. So when we filter data, business gives us proposition or combination of propositions that we use to filter our data. So let's give an example. Business tells us, find all records in the sales report where sales rep is equal to Clara. We go for each record and ask, is this Clara, is sales rep is Clara? It's true, then we need to show this row. If sales rep is Alex, our proposition sales rep is Clara is false, we don't show that row. So table gives us ability to just say select Alex, and it will filter out everywhere proposition is true. What I like to do is, if we have simple propositions, very often Excel already gives us tools to do it, but we still need to think about those propositions, what we're doing, even in a simple possible case. So let's do queries. Sales rep equal Clara. So we can just select and pick Clara. Another way we can do, we can add a column here in our table, and we put a formula. So I call this proposition number 1, sales rep equal Clara, and I call this column proposition number 1. So I have a formula that this column sales rep is equal to Clara. This returns as true when it's Clara and it's false when it's not. So I can also search by this column. Give me where sales rep is Clara, where this proposition is true, or I can say give me when it's not Clara. So that's going to filter out everybody who is not Clara. So why would I use this proposition column if I could just come and pick here? Well, it sounds pretty easy. There is really no need, maybe you may think. But here in a drop down, we have only 3 sales rep, but we have 5,000 of them here. It's sometimes easier to build this propositional logic that would actually look up and give us true if this sales is part of the people I want to filter by, then actually go and manually check them all out to check them all in. So that's why I like to think about those proposition columns. Sometimes we just don't need to build them, but in the real world, in the complicated cases, we do. That's why we cover it right now here. So sales rep is Clara. We can just pick Clara from this list of sales rep, or we can build proposition column where sales rep Clara and filter by this propositional column. Same thing, sales rep is Alex. We can pick Alex here. And my proposition 2 is formula. Sales rep is Alex. You can see they're all true here. If I will come here and say I want to all sales rep that's not Alex. So what the proposition is? Sales rep is Alex, but then value is not. Not is reversing our proposition. So this is also proposition. If sales rep is equal Alex is a proposition that answer is true. Sales rep is not Alex, it's also proposition because it also has answer true or false. Let's look at this particular row. Sales rep is not Alex. That question is false. It is Alex. Sales rep is not Alex. Well, sales rep is Bob. Yeah, that's true. That's true. So my proposition 3, proposition 4, sales rep is not Alex. Proposition 4, sales rep is not Alex. So for Alex is false, but for Bob, that's a true statement. Sales rep is not Alex. So if I want to find everybody who is sales rep is not Alex, I can come here, unselect Alex. That'll give me all sales reps that are not Alex. Or I can come to this proposition. I can come to proposition sales rep is Alex, which is proposition 2, and pick value false. That will give everybody who is not Alex. Or I can come to this proposition that I built proposition 4, which is formula sales rep is equal Alex not sales rep is Alex. I can just pick when it's true. That will give me everybody who is not Alex. And if I pick it false, that will give me everybody who is Alex. So I want you to think about it, play with it. Propositions can be combined. That's kind of confusing maybe for some people, but if we have proposition sales rep is Clara, that's a proposition. Sales rep is Alex, that's another proposition. Now question, sales rep is Clara or Alex, that's a proposition, that's a statement that can be also answered with true or false answer. So let's just manually go through this. Sales rep or Clara or Alex? Clara or Alex? That's true. Clara or Alex? True. Clara or Alex? That's false. So, or means it's true if first proposition is true or second proposition is true, right? Clara or Alex. So this is what I have here. Or if one of them true, another false, then proposition or is true. If one of them false, another true, proposition is true. So it's either one of those propositions is true, then or proposition is also true. So if I want to find sales rep Clara or Alex, I can just come here and I'll select Clara, Alex. So it'll be Alex or Clara. That's what it or means, Alex or Clara. Alex or Clara. That's an or statement. We took two propositions, and by selecting two sales rep, we just did an or statement. Sales rep equal Clara or sales rep equal Alex. We also can combine proposition with what we call AND operation. The AND operation says both propositions have to be true for the final proposition to be true. Sales rep is equal Alex and sales amount on the record has to be 100,000. What does it mean? If sales rep is not Alex, then this whole thing is false. Let's look at this row. Sales rep is equal Alex and sale amount greater than 100,000. That is false. Sales rep is Clara. Sales rep is Alex and amount greater than 100,000. That's true. Both of them is true. Sales rep is Alex. Sales amount greater than 1,000. Both of them is true and is true. Sales rep is Alex, but sales amount is 52,000. This is true. First proposition is true. Second is false and is false. So I built this proposition number 6 formula, and sales rep is Alex and sales amount greater than 1,000. Greater than 100,000. So this proposition, if I select when it's true, it will give me all Alex's sales with amounts of greater than . I think I had not 100,000. I think I have here, let me see, 1, 2, 3, 10,000. So let's add 100,000. Yeah. And let's select true. There is only one row that qualifies to this AND statement. It's Alex and sales amount is 100,000. So let's kind of go through these examples here. Sales rep is Clara and then order by quantity descending. So I went and picked sales reps are Clara, and once I got the sales, I go to quantity and select it largest to smallest. So after we did the filtering, then whatever we filtered, we can sort. You can do this proposition 1 is true because it's proposition 1 means Clara. Okay. You may notice the way I write it is say where sales rep is Clara, order by quantity descending. So why do I put it in this where statement? That's because I'm trying to prepare you to SQL. This is how in SQL we will specify our queries. So similar logic, as you can see, the same type of filtering and ordering is used in querying SQL Server databases or SQL databases in general, SQL databases in general. So we want to find all the records where sales amount greater than $50,000. So what we're going to do is, let me clear that. Basically, we're going to go through each record and find if sales amount greater than 50,000, then we want to see it. If it's less, if greater than $500, if it's less, we don't want to see it. And if we order smallest by largest, we can see that we really have only one record that we should not see if we apply this filter. So let's do it. Let's do the filter. We can just go ahead, unselect, or select everybody and unselect. Select all the records and unselect this. That will do it. Not a good idea. Why? Because if we will add more records to this table, data will change. It may not be $240. We may have another sale at $50 and it will show up. So not a good idea doing it this way. Better to use number filter. And here we can do, give me all the sales greater than $500. And that sale less $500 is disappearing. Well, we can also do another, clear this, select, number filter, greater than $500 and less than, let's say, $100,000. So this is an end statement. It says go through each record and do 2 checks. If it's greater than $500, if that's true, then also check if it's less than 100,000. And if one of those 2 propositions are false, then don't show me that record. So if it's greater than $100,000, don't show me that record. If it's less than $500, don't show me that record. So here's selection. So even though you're using the tool, always think that you can actually build a propositional column. Let's do it. Let me insert table to the right, and I'll call it propositional 7. I can build the same type of propositional logic by saying and sales amount. So let me first remove this filter. So sales amount greater than $500. And sales amount less than $100,000. So now this is true, false, right? If it's false, it means that it does not fit. Less than, this one is, let's look at what's false here. False. This record is too small, this record is too large. And true, they fit within that range. So we can use propositional logic, or we can just do using the tool, but we still use propositional logic. The tool just help us out. But it's very important to think what you're actually doing. Where sales rep is equal to Clara, all sales rep is equal to Alex. Again, we can just pick sales rep Clara, Alex, and you can see proposition 5. Sales rep is equal to Alex, and sales amount greater than $100,000. Again, we can just pick sales rep is Alex, greater than $1,000. So, very important to know that you can do filter and then you can sort the filtered results. After you're done with this lecture, I encourage you to look at homework. We actually used the data set from responses, from survey responses to our class. We made it anonymous by replacing department names, removing your names, and removing your comments so that you would not be able to identify who submitted these responses. But we have a data set we just created right for our class to identify what are your interests and what's your knowledge, current knowledge, when you enter the class. So the first homework that I'll ask you to do is to build, and by the way, for each homework there is an answer. So you should try yourself to do what I'm asking you to do, and then you can look up the answer, and if you have an issue you can send me an email and I'll try to help out. What I will also do is I will record the explanation for homeworks. So what I want you to do is I want you to build columns. You indicate, so here's some response from some person from department 19. He indicated that he has Excel experience and SQL Server experience. So what is his SQL experience? He indicated as basic, advanced, intermediate. So I want you to map this column I call SQL level. So every time that somebody said he has novice experience, I want you to put level to 0, basic to 1, intermediate to 2, advanced to 3. So if you look at the answer, SQL level is 1 for basic, 0 for novice, 3 for advanced. There is a formula here. I want you to figure out that formula. So homework number 2. You get the same data set already figured out with those columns. I want you to sort this data set by ID, smallest to largest. Now it's sorted largest to smallest. In homework 3, I want you to find all records so in the first homework you'll be doing a lot of mapping. One of the last columns will be enrolled in class. If ID is less than 16, then you enrolled in the class. If not, then you're in the waiting list. So in homework number 3, find all records where enrolled in class equal true and department either department 14, 25, and department 1. And once you got that result, I want you to order this result by ID, smallest to largest. Homework number 4, I want you to build multiplication table, function table for x and y, and I want you to implement this function, x squared plus y squared plus a plus b. Here's our a, here's our b. Okay, so I want you to implement it, and there is an answer to it. Thank you very much for your time, and I'm looking to see you in the class tomorrow.